Now it's time to open up Pro Manufacturing and put some operations and steps on here. To do that, the first thing you'll need to do is go to Tools, Floating Modules, and we're going to need to pick a license, essentially. I'm going to use NC Advanced. Kevin, what other ones can we use?
The only other one that will work for this is NC Advanced Machining Set.
Apparently, they both do the same thing. Is that right?
Yes,
But we just need one or the other.
correct.
All right, so we're just going to go with NC Advanced for now. And what happens if too many people are on at the same time?
You may run out of licenses, which means it will not be available to select.
Okay. So this is where you go to pick that license. If the one you want is not available, try the other one. So now we have that set. We can create a new manufacturing part. So we'll go New. And you just choose Manufacturing. Give it some name that's unique. We'll go to our templates. I'm in inches and pounds, so I'm going to use inch pounds manufacturing. May not be right, but I guess I don't really care. So here we go. It pops open your test manufacturing. Very important step here. Most times when you open this, it's going to open up as Expert Machinist. Oops, there it goes, Expert Machinist. And you won't see anything you like. It's going to give you a whole bunch of grayed out buttons and a whole bunch of things that don't work. So make sure you change your application to manufacturer. There we go. So now we're in manufacturer mode. It's really just an assembly, but you've got some special picks. The first thing to do is to add in your part. Assemble reference model. That means add part. There's my part. For now, I'm just going to define this with its default. That'll work good enough. We've talked a lot about whether we should set this up particular to a coordinate system or add coordinate systems on. But Kevin, why is it that it doesn't really matter where your coordinate system is?
A lot of what we're going to do with this example is going to be controlled in our post processor. Speeds and feeds, and also the coordinate system for the machine will be controlled by that specific post processor.
Okay, so as we go, you'll see that I'll be setting some feeds and doing things like that. Those aren't necessarily going to matter once it gets through post processing, but we'll do that so that you can see the toolpath play live, which is really very important. It's a good way to debug. So now we have our part in, and I need to take you through kind of how this is set up. It can be a little confusing, so be careful here. What we'll be talking about is we'll be talking about operations, machines, tools, and steps. An operation encompasses several steps and is applied to one machine. In my opinion, it's a little backward because I would think of it as a machine, but we're going to think of it as an operation, and we're going to put a machine on the operation. So that's the first thing we need to do. We're going to create an operation. And the first operation we want is on our, we'll call it milling. We don't need to be real fancy here, but it's nice to have something meaningful. We're going to pick a machine. For our purposes, I'm going to use the machine that already comes in the system here, machine 1. It's a 3-axis mill. We're going to pick our 0. Now it is fairly important that you have your z-axis in the right orientation. So I want to make sure that I get the right z-axis here. Let's see if there we go. We have z pointing up, as the tool would see it. And I'm going to draw my retract surface in. Again, this may not be completely necessary, but this would be the clearance for the tool. I'm going to put that in there just so we have it. Okay. You'll see over on the left we've set up our operation, which ironically has the machine listed first, a setup, machine, and then here this milling is our operation. Beneath this we'll put our various steps. So the first thing we wanted to do was to trace out the outside of the part, and we're going to do that with a custom trajectory. That's a step. It is called custom trajectory. There we go. 3-axis. Yep, that's what we want. You'll see over on the right, you'll get a little menu. It has some things pre-clicked for you. We're going to go ahead and go with just what it has. It's going to ask you about the tool you want to use. So the tool I want to use, I'll get that out of the way, doesn't exist yet, but we do want a 1/2-inch end mill, so that's good. It'll be named T001, we'll apply it. There we go. It's 4 inches long, 1/2 inch diameter, that's fine. Just close that out of the way. That's the tool we'll use. We've established our tool, and now we need to put in some cut feeds and clearances and things like that. As Kevin pointed out, the post processor will really do most of this, so I'm just going to throw some numbers in here so we can get something to run. If you don't fill in the yellow sections, you won't get anything to work, and you really want to be able to see the path so you know you've done it right. Okay, this can be a little bit of a trick here. It doesn't really prompt you, but you need to select now the path that you want. To do that, you're going to have to do an insert. So we do an insert. This can also be pretty tricky. It's going to give you a lot of these little menus, so follow along close. It's just asking you questions. It's not asking you to do anything yet. We want a curve. Let me see it. Here we're going to hit done. Well, I hit done, I don't know. But we hit done, and now we want a curve chain. The reason we do a chain is we want to make sure we get the entire loop no matter what happens to it. So now I can pick. It's ready for me to pick that. It asks if I want to select all. You know, if it says select all, you know you're going the right way. There you go. Looks like you're not done, but you are. So you hit done. Now it's going to give us an arrow with a direction. Kevin, is there any significance to this arrow?
No, not for our toolpath that we're creating.
Okay, so you can run it either direction. Hit OK. Now it's going to ask you about the side that the tool should be on. If you're running the mill, you'd want the tool to be, in this case, on the left side, so it's not digging into the part. But we're not going to do it that way. We're doing centerline machining. Is that what you call it?
Correct.
So in centerline machining, we're going to pretend like the tool's going to run right through the center of this edge, and we're going to let the post-processor figure out where it really belongs.
Correct.
Okay. So here we go. We'll hit done. Now, don't lose what you got here. You want to make sure this sticks, and to make sure it sticks, you hit done cut. There we go. Good. We're seeing a tool in our path. That's great. Hit OK. Now let's play it and see what it looks like. Hit play path, compute CL, screenplay. It should give us a little window. Yes, it does. A little pop-up there. And you have a speed controller. You can adjust the speed of your playback, and you can just hit play and stop and all that stuff. Oops, we're going fast. See if you can see that again there. Yeah, let's see if we can see that again. And I'll go backward. There we go. And forward. And you can see it went all the way around the part. It looks about like we like. That's good. Now make sure you hit done sequence. Don't hit next. Don't hit quit. Make sure you hit done. There you go. Now we have our path all the way around the outside. And it should be pretty robust. And we'll demonstrate that in a few minutes.